Hello. So today we will start nuclear physics, and in the nuclear physics we will start the topic of the radioactivity. So what is the radioactivity? See, we know that radioactivity means disintegration or breakup a nuclei spontaneously with emission of some electromagnetic radiation of very high energy. Okay, so let's start radioactivity. Okay, हम जानते हैं, we know that in the nucleus, few nucleus are already in the ground state. Okay, and those nucleus which are in the ground state are the stable nucleus. Okay, and once they are formed out of the requisite number of neutron and proton in a particular quantum state, which is the ground state, they will remain in that same state for indefinite period of time. Okay, unless otherwise डिस्टर्ब, जब तक उन्हें डिस्टर्ब नहीं किया जाएगा तो कोई स्टेबल न्यूक्लियाई है तो उसके जो अंदर जो न्यूट्रॉन प्रोटॉन है वो वैसे ही रहेंगे, है ना. बट वी नो दैट देयर इज ए क्लास ऑफ न्यूक्लियाई एंड देयर आर न्यूमरस काइंड ऑफ न्यूक्लियाइज विच आर अनस्टेबल. ऐसे बहुत सारे न्यूक्लियस हैं जो अनस्टेबल हैं, जो ब्रेक हो जाते हैं, टूट जाते हैं, स्पॉन्टेनियसली डिसइंटीग्रेशन होता है with emission of some rays. In the first case, see, either the atomic number Z or the mass number A. Suppose you take atomic number A or mass number Z. Okay, so whenever nucleus disintegrates, जब भी nucleus कोई टूटता है, so either Z will change, either A will change, or either both will change. Okay. Okay. And sometimes nucleus just goes from one quantum state to the another quantum state. So the phenomena in which there is a spontaneous transformation of nucleus, a spontaneous breakup of the nucleus, that phenomena is known as the radioactivity. So the phenomena of the spontaneous transformation or spontaneous decay of nucleus is known as radioactivity. Okay, so that is the definition of radioactivity, usual definition. And we know that it is first, this phenomenon is first discovered by French physicist Henri Becquerel in 1896. So credit goes to Henri Becquerel. Okay, and we know that radioactivity was discovered almost by accident, just like X-ray discovered by Roentgen. Okay, accidentally. Okay, so similarly radioactivity is also discovered accidentally. Okay, so we are not going to discuss what is the historical reasons or historical way. Okay, so that you can study in the history of science, but we will discuss the technical details and see in the radioactivity. Madame Curie and his husband Pierre Curie awarded within Becquerel Nobel Prize in 1903, okay, for the radioactivity discoveries. So in this video we shall discuss radioactivity decay laws of alpha, beta and the gamma rays. Okay, so as I already told you that radioactivity is the phenomena of spontaneous disintegration. Okay, and in the form of the electromagnetic radiation or some other radiation. Generally heavy nuclei in which neutron proton ratio is greater than 1.5 decay in this way. Example is uranium or radium. So in the uranium or in the radium, the ratio is just greater than 1.5. So neutron numbers are greater than the proton. Okay, and there is no physical or chemical change. Okay, so means there is no atomic level changes. Okay, whenever nucleus disintegrates, so there is no change in the atomic level. Okay, so it is a nuclear property of the atomic element. In all radioactive process, a transmutation of element occurs and altogether new nucleus is formed. After disintegration of the heavy nucleus, some another nucleus will form. Just like in uranium, if there is some radioactive decay, after the decaying, that nucleus will become some another nucleus. I will give example. See, generally we observe there are three kind of the radioactivity rays: gamma rays, alpha rays, and the beta rays. There are three kind of the rays. And what are the radioactivity laws? See, alpha, beta. Alpha are the positive nucleus of the helium. Beta are the negative electrons, and gamma rays are the neutral. These are just electromagnetic waves. So there is a radioactive decay law. What are radioactive decay laws? See, on emission of alpha or beta rays, okay, which is usually but not invariably accompanied by gamma ray emission. मतलब कि जब अल्फा और बीटा रेज निकलती हैं तो जनरली उसके बाद में गामा रे एमिशन कई बार निकलता है. जस्ट जो आपका डॉटर न्यूक्लियाई है, तो कई बार अल्फा रेज निकलने के बाद क्या होता है, न्यूक्लियस एक्साइटेड स्टेट में रहता है, या बीटा निकलने के बाद भी एक्साइटेड स्टेट में रहता है. तो उसके बाद में जैसे गामा रेज निकलती है ताकि वो अपनी एक्साइटेड स्टेट से डी एक्साइटेड स्टेट में आ जाए. ओके, सो जो पेरेंट न्यूक्लियाई है, आफ्टर द decaying of alpha, beta or gamma rays, it will convert into the daughter nuclei. And daughter nuclei may be again radioactive or maybe not radioactive. So there is a process of the successive disintegration. If the daughter nuclei जो पैदा हुआ है आफ्टर द पेरेंट न्यूक्लियाई, अगर वो रेडियोएक्टिविटी को फॉलो कर रहा है तो ये चेंज चलती चली जाएगी कंटिन्यूस. तो सक्सेसिव डिसइंटीग्रेशन चलेगा. कब तक? जब तक कि एक स्टेबल न्यूक्लियाई फॉर्म नहीं हो पाता है. जो हमारा ओरिजिनल था न्यूक्लियाई, वो पेरेंट न्यूक्लियाई था, ये कन्वर्ट होगा किसी डॉटर न्यूक्लियाई में. अब हो सकता है ये भी फिर से अल्फा बीटा गामा रेज निकाले और ये फिर से कन्वर्ट हो जाए किसी और डॉटर न्यूक्लियाई में. ये फिर से निकाले और करते करते फाइनली तब तक चलेगा ये सक्सेसिव डिसइंटीग्रेशन जब तक कि हमें एक स्टेबल न्यूक्लियाई नहीं मिल जाता. ठीक है. तो एंड सी द रेट ऑफ रेडियोएक्टिव डिसइंटीग्रेशन, the rate of radioactive disintegration, that is the number of atoms that break up at any instant of time t, is directly proportional to the number of active nuclei present in that sample. मीन्स हम बात कर रहे हैं कि जो रेट है किसका, डिसइंटीग्रेशन रेट, न्यूक्लियर के टूटने का जो रेट है किसी भी टाइम पे, वो इसी बात पे प्रोपोर्शनल होता है कि उस टाइम पे कितने न्यूक्लियाई प्रेजेंट हैं. माइनस साइन शोज दैट न्यूक्लियस आर डिसइंटीग्रेटेड, मतलब ये टूट रहे हैं, कम हो रहे हैं, बढ़ नहीं रहे हैं. सो दिस इज द वन ऑफ द लॉ. सो लेट्स फाइंड आउट द डिके इक्वेशन. व्हाट विल बी द डिके इक्वेशन? सी वी नो दैट Nt द नंबर ऑफ एक्टिव न्यूक्लियस प्रेजेंट इन एनी सैंपल एट एनी टाइम, जो कि डिके हो सकते हैं. and in any experimental data it is our survey. So we can remove proportionality sign and we can put some constant here. Maybe constant is lambda. So equation will be this. Okay, maybe equation. What is the lambda? Lambda is the constant of proportionality, and generally it is known as the decay constant. Okay, it is a constant for a particular nuclei, and negative sign hints that n actually decreasing with the time. So negative means decaying. And to solve this thing, just put n one side and t one side. And just integrate. So dn over n will give you log, and lambda dt will lambda t plus a. A is some constant. Is a constant of integration. We can easily find out with the help of the limit. And with the help of the limit means at t is equal to 0, the nuclei are n naught, initial nuclei. So then what is A? So A is log n naught. Okay. So put the value of A in equation 2, log n t is equal to minus lambda t plus A is log n naught. Just put log one side and log n t upon n naught, or n t upon n naught is exponential minus lambda t, or further you can write down it as n t as n naught exponential minus lambda t. It is the final equation. So it is the equation of the decay. So that's why it is known as the decay equation, radioactive decay equation, where n naught is the number of nuclei at t is equal to 0, nt are the nuclei at any instant of time t, okay, which are the remaining nuclei. It's not a decay nuclei. Whatever the nuclei, number of nuclei is present at any time t, that is the nt. Lambda is the decay constant and t is the time. So with the help of this decay equation, we can easily calculate the half-life. What is the half-life? Half-life क्या होता है? See, half-life of any radioactive nuclei is defined as the time t half, in which the original amount of the radioactive atoms reduced by half of its value. Okay. So at t is equal to t half, the number of nuclei will be half. Okay. So we can put this value in the equation 3. So n t is n naught by 2, and it is n naught exponential minus lambda t half. N naught we can cancel, so it is 1 by 2 is equal to exponential minus lambda t half, or t half is equal to log 2 upon lambda. Okay, it is the formula of the half-life. Okay, or if you put the value of log 2, then t half will be 0.693 upon lambda. Okay, so or lambda into t half is a 0.693 is a constant. Okay. So as you calculated the half-life of nuclei, similarly you can calculate the average life of the nuclei. What is the meaning of average life of nuclei? Average life of nuclei का मतलब है कि जब भी न्यूक्लियर डिके होंगे तो कुछ न्यूक्लियर तो ऐसे होंगे जो तुरंत डिके हो जाएंगे, कुछ ऐसे होंगे जो बहुत टाइम के बाद होंगे. जैसे कोई इंसान हो सकता है कि पैदा होते ही मर जाए, कोई हो सकता है 50 साल में मरे, कोई हो सकता है 100 साल में मरे. बट हम एक एवरेज लाइफ निकालते हैं, है ना, स्टैटिस्टिकली, तो हम कहते हैं कि एवरेज लाइफ ऑफ ह्यूमन बीइंग इज लाइफ इज 70 और 75। तो इसका मतलब ये नहीं कि हर इंसान 70-75 जी रहा है, तो ऐसे यहाँ पे भी न्यूक्लियस की एवरेज लाइफ निकालते हैं एंड इट डजंट मीन्स दैट ईच न्यूक्लियाई विल डिके इन दैट टाइम, ओके। एवरेज लाइफ मीन्स इज द स्टैटिस्टिकल एवरेज, okay. So few nuclei can decay before the average life, or few nuclei can decay after the average life, but it is just a statistical average or the mean life. So average life or mean life, see, the average lifetime or the mean lifetime, which is a T so it is the average lifetime of all the nuclei in a given sample, okay, as a ratio of the total lifetime of the all the nuclei to the total number of nuclei. So T is, see, life of one nuclei and number of nuclei जिनकी लाइफ T1 है, प्लस dn2 नंबर ऑफ न्यूक्लियाई, इनकी लाइफ T2 है, एंड सो ऑन, और नीचे टोटल नंबर ऑफ न्यूक्लियाई, T1 लाइफ के न्यूक्लियाई, T2 लाइफ के न्यूक्लियाई सो इट इज दिस TDN 0 to infinite, एंड यहाँ पे क्या होगा, जीरो नहीं है, पहले ज़्यादा थे और बाद में जीरो हो जाएंगे जब सारे ख़त्म हो जाए। टाइम तो बढ़ रहा है इन्फाइनाइट तक, क्योंकि सारे न्यूक्लियर ख़त्म होने में इन्फाइनाइट टाइम लगता है, क्योंकि एक कंडीशन के बाद में स्टेबल हो जाएंगे और स्टेबल न्यूक्लियर डिके नहीं होता, तो कोई भी न्यूक्लियर पूरा डिके होने में इन्फाइनाइट टाइम ही मानते हैं। And it is minus n naught, okay. But we know that what is n? N is n naught exponential minus lambda t. So dn will be this, okay, and just differentiate this minus lambda n naught exponential minus lambda t, which is n. What is the T? Average life is this lambda. Just put the value in the previous equation, this equation, okay. Put the value Dn, n not cancel हो जाएगा, lambda T minus lambda T dt 0 to, because n not will cancel out. Just solve this integration and you will find out, it will give you value of 1 by lambda. Just solve this integration, it's very easy. So total average life is the inverse of the decay constant, okay. Or you can say that total life is the 1.4 times 44 times of the half life, okay. In that way we can relate the average life of the nuclei and the half life of the nuclei, okay. So this is the short description of the radioactivity, and after that we will discuss radioactivity series, okay. How radioactive element transform when it decay alpha particle or beta particle or gamma particle, or what are the activity, what is the meaning of the activity, and what are the decay series, okay. Thank you.